Okay, I have some really cool news for you today. Researchers at McGill University have recently announced a newly developed process that could have really big ecological implications. It's one of those technologies that's awesome, but it seems like it might never make it out of the lab because of issues scaling it up, or because it's too expensive, or some other reason. Except, in this case, it can be scaled up, and it's economically viable, so it's very, very likely to make it out of the lab and into consumer products. And as you're about to find out, that's a really good thing. The research was led by Associate Professor of Applied Chemistry Audrey Moores and her graduate student Thomas DiNardo. And the context of their experiment is that they were searching for a way to more efficiently produce the chitin-based plastic Chitosan. Chitin is a biopolymer compound found in the hard shells of arthropods, including insects like beetles and cockroaches, and crustaceans like crabs and lobsters. It's also found in the cell walls of fungus, but it's not really economically viable to harvest fungus for the chitin to make plastic. It's hard enough as it is with arthropods. The exoskeletons and the hard plates of these arthropods are harvested for the chitin, which can be turned through an intensive process into the plastic chitosan. But it's mostly used to make very small pieces of plastic that have a medical application. In other words, it's difficult to scale this process up to make large quantities and large pieces. It's pretty expensive, and so it really only finds use in the medical field. The breakthrough was that Professor Moores and Mr. DiNardo have developed a way to produce chitosan without extensively breaking down the polymer. They found a way to transform chitin into chitosan while retaining the structure of the long-chain polymers. Professor Moores said, quote, "This is opening an avenue of possibilities. We just created a new material, essentially. We have a much safer process, causing far less pollution and far less waste." Unquote. In effect, they can safely and economically scale up the production of chitosan. Because this research has obvious market potential, the details of the chemical process are confidential. They've filed a patent on the chemical process, and they have plans to commercialize it. The hope is that they can use this chitin-based plastic to replace the plastics that are made from petroleum. This is good news for the Earth's climate, because chitin harvested from insects is already in the carbon cycle. If we use that, we don't have to dig up petroleum, which takes carbon that's been locked deep underground for millions of years, and return it to the carbon cycle, where it warms the atmosphere and makes the oceans more acidic. If we use this chitin-based plastic instead, we won't have to do that. Even better, the chitosan that they produced is biodegradable, so it can't really contribute to pollution. Where petroleum plastics generally aren't biodegradable, and they'll wear down and create microplastic particles that contaminate everything, a biodegradable plastic will simply be consumed by other organisms living in the environment until it's been fully metabolized. There really isn't that much risk of microplastic contamination, which is a big plus. Now, their current research is trying to find ways to modify their chitosan so as to make it more flexible, which will create a wider range of the types of chitosan plastic out there, with a wider range of commercial applications, from biomedical uses to 3D printing. I really hope that this stuff finds its way out of the lab and gets widespread commercial application, because a biodegradable plastic that doesn't require petroleum would be an incredible step forward. It would be a huge win in the global effort to prevent pollution and climate change.